So this section, I think for many people becomes a very cryptic and challenging section. It's very difficult to make sense of what's going on and how to actually accomplish the task of basic translation for predicate logic. I worked really hard on this video to come up with several different ways of thinking about the concept of translation, and I hope one of them sticks for you. At the end of the day, if you can accomplish a translation correctly, whatever method you're using to do that, just stay with it, find what works for you, and go with it. So here we go. This is going to be a long video because there's a lot of information to get out here. I try and take the complex ideas and make them as simple as possible, but that means I got to take a lot of time to go through it in that simple way. So you're just going to have to bear with me. My recommendation is to watch this 3 times at least. The first time, just watch it, don't take notes. The second time, watch it while taking notes. And the third time, watch it. And then as you see me start to do exercises, hit pause before I do them on your own and see if you get them right. And then if I were you, I would just keep watching the video, doing those exercises. Just repeat the exercises part if you need to, until you can get them all right by yourself. And once you can do that, then start doing the actual homework exercises. Okay, let's get going. So the basics of predicate logic, there's 2 things we need to know, but before we do that, we need a little refresher. Okay, first a refresher. A new way of talking about familiar ideas. So we're familiar with simple statements in that they consist of a subject and a predicate. This is old translation issues. The subject is what you're talking about. The predicate is what you're saying about the subject. No operator is involved. So for instance, Matthew likes pizza. That has a simple subject, which is Matthew. It has a predicate, likes pizza. That's what Matthew's doing. And then compound statements consist of at least one operator separating simple statements. So for example, Matthew likes pizza and Jovita likes asparagus. You have statement 1 is Matthew likes pizza. The subject 1 is Matthew. The predicate is pizza. That's the first predicate. Statement 2 is Jovita likes asparagus. The second subject would be Jovita, and the second predicate would be asparagus. And the operator there would be and. Remember, negation is a pain in the neck doing its own thing. It's an operator, but it doesn't connect 2 separate simple statements. So let me really quick walk through these to go back to the old school translation that we should all be familiar with. For the first example, Matthew likes pizza, I would just say P for Matthew likes pizza. For the second example, Matthew likes pizza and Jovita likes asparagus, I would do something like P for Matthew likes pizza, a dot for that operator, that conjunct, and what does Jovita like? Asparagus. So pizza and asparagus. There you go. And I'd be done with that. And then I'd remember that negation is this weird one because it doesn't connect the separate simple statements. It just modifies. So for instance, if I said Matthew doesn't like pizza, then you would go negation P. So you have the various approaches. The thing that I really want you to focus on now is that for the first example, Matthew likes pizza, that is a single simple statement. For the second example, Matthew likes pizza and Jovita likes asparagus, that is a compound statement consisting of 2 simple statements. And that's kind of the background that we need. And then the final thing is, even though there's an operator involved in a negation, it still is operating on a single simple statement. It is not connecting 2 simple statements into a greater statement. Let's go ahead and move on to the next slide. So the first thing we need to know is if we start with this familiar statement, let's say Matthew likes pizza and Nicole likes lasagna. Our familiar translation format is that each statement gets a letter. So Matthew likes pizza gets a P, Nicole likes lasagna gets an L. The operator goes between the statements, so P dot L. Now for a more complex statement. Matthew likes pizza and Matthew likes lasagna, and Nicole likes pizza and Nicole likes lasagna. What if knowing who likes what is important to our argument? So I'd like to translate Matthew likes pizza with a P. So going over to the first part, Matthew likes pizza. I'd like to translate that with a P for the pizza part. But Nicole also likes pizza, and so that might get us confused because, well, who are we talking about who likes the pizza? If I use an M, what do I do with Matthew liking lasagna? So if we said, well, let's make it an M for Matthew liking the pizza as opposed to Nicole liking pizza, but then we have this Matthew liking lasagna as well. And then if we use an L for lasagna, well, what about, again, Nicole liking lasagna? We already kind of brought that issue up. So it gets a little cumbersome here if we want to be kind of really specific with what's going on in our statements. Predicate logic allows us to get more specific with our sentence analysis. Okay, so here's how the first thing to know works. First, specifically named things are a piece of cake to translate. All you have to do is make the predicate a capital letter on the left and the subject a lowercase letter on the right. So for instance, if you have Matthew likes pizza, Matthew is the subject. That is going to be a lowercase letter on the right. And then you're going to have liking pizza is going to be a capital letter on the left. So there you have it. Matthew likes pizza. Another example. Matthew likes pizza and Nicole likes lasagna, or Nicole likes pizza and Nicole likes lasagna. So there's a lot of little simple statements going on here, but they're going to work on the same principle. We're going to have the predicate on the left in capital, the subject on the right in lowercase. So Matthew liking pizza. We're going to say pizza is what Matthew likes, and the person doing the liking is Matthew. Then we have Matthew likes lasagna, so we're going to go L for lasagna. Who does the liking? That's Matthew again. We have or is that operator that we're connecting these two statements. And then we have Nicole liking pizza, so we're going to go another capital P for liking pizza, but this time it's going to be Nicole who likes the pizza. And Nicole likes lasagna, so we're going to have Nicole liking lasagna. Who likes the lasagna? The lowercase n for Nicole. So there's our subject and our predicate. And we put those in parentheses, just like the way the old school system of translation worked. So this isn't too painful, I don't think. This works for specifically named subjects like Matthew or Jupiter or Jovita. It doesn't work for non-specifically named things like a person or a planet or another person or all people. So non-specifically named things like some people or a planet or all people are tough to work with. We need to approach these from a different mindset. Moving on to the second thing we need to know. So let me move slides and we'll start working on that different mindset. The second thing we need to know is that non-specifically named things like a cat or all cats or some people involves quantifiers. The difference between a specifically named thing and a non-specifically named thing, I would say Garfield the cat is a specifically named cat. But then if I say a cat or all cats, I haven't specifically named any particular cat. So I'm not saying like Garfield. Or if I said Snoopy, that's a specifically named dog. But if I said a dog, a hound dog, they're still not a specifically named thing. Okay, so quantifiers, what are those? The first one we have is the backwards E and an X. It's just a capital E backwards and X, lowercase x right after that. And that means at least one, and we put that in parentheses always. The second quantifier is a lowercase x put in parentheses always as well, and that means all. So those are the two quantifiers we work with. We work with the sum quantifier and the all quantifier. The sum quantifier, the backwards ex, just means at least one, and formally you would say there exists an x such that, and then the lowercase x quantifier just means all, and formally we would say for every x, and then continue. Okay, these statements will add to them: 1, a quantifier; 2, a variable to stand in for the subject; 3, a capital letter to stand in for the predicate or predicates; and 4, a quantifying operator. Quantifiers work like a negation, so they're going to quantify whatever is directly to their right. To quantify a compound statement, the whole statement needs to be in parentheses. And in the same way a negation negates everything in parentheses, a quantifier quantifies all of the variables in the parentheses. Now, this slide, I'm going to go through a couple of examples. If you're completely confused right now, don't worry, there's a bit more to go. At this point, I just want to get some information out for you. We'll keep working on clarifying, so I don't expect clarity from you right now. If you're scratching your head, you're totally in a fine spot. Okay, example, all trees are green. So this is all trees. In that case, we're dealing with the universal quantifier, which is the all quantifier, the x one. So I'm going to put an x first. And you don't have to understand why I'm doing it right now. Just I want you to get familiar with what's happening. We have trees are being talked about and green things are being talked about. So I'm going to say if X is a tree, then X is green. I'm going to put this in parentheses. Okay, here's what all this means. You have for every X, if X is a tree, then X is green. For every X, if X is a tree, then X is green. And so the quantifier is the X. The variable standing in for your subject is going to be this X, the lowercase x that's repeated after your capital letters. That's the variable. Then you have the capital letters standing in for the predicate or predicates, so the capital T and the capital G. Now at this point, some of you are saying, wait a minute, trees is the subject. I agree with you, you're correct. However, in a sense, we're going to say there's a deeper subject, and that deeper subject is this variable X. And we'll talk about that more as we go along. And then finally, you have a quantifying operator, which is the X. Okay. Okay, let's work on the second sentence now. Some cars are blue. Here, some is going to be a particular statement, and so we're going to go with an EX, the backwards E, and the X. We're going to say that some of these X's are cars, so we're going to go CX, and some of them are blue. So there exists an X such that X is a car and X is blue. We want to be sure that the quantifier is connected to both of the variables, both of those X's, the one after the C and the one after the B. So I'm going to put both of those variables in parentheses, and we're done. So what this statement says here is there exists an X such that X is a car and X is blue. Let me rewrite the top one so you can see the difference between those two things. For every X, if X is a tree, then X is green. Now, again, so we have probably some observant students saying, wait a minute, why are you using a horseshoe up top and a dot down below? This is the operator that's governed by the quantifier, and the operator that's governed by the quantifier is going to change depending on what quantifier you're going to use. I'll talk about this more in a second, but just for now, know that the X, the operator that it governs, is going to be a horseshoe. The EX, the operator it governs, is going to be a dot. Okay, so let me now move into the discussion of the subject. So just a second ago, I was saying X is the subject, and I'm sure some of you are saying, but I thought trees, not you thought, you know trees are the subject. And so why can I say X is a subject? Let's start talking about that now. Okay, how to think about quantified statements. There is a variable X in a simple statement. The variable functions as an undefined blob. The undefined blob is the subject. The simple statement is used to define the blob. The whole simple statement is the predicate. The subject and the predicate of the simple statement all function as predicates for the blob. Wait, what? Yes, the subject and the predicate of the simple statement both work as predicates for the blob. So when I say all cars are fast, you're going to have an X that's going to be the blob. Then the subject of your statement, cars, and the predicate of your statement, fast, are both going to define the blob. So these two things both work together to define the X. So you have an X, and then you have the stuff that works together to define the X. For example, let me erase this stuff now. Some cars are broken rust buckets. The variable, or the blob X, is the subject. Now we're going to add the predicate car, broken, and rust bucket to the subject. So let me write the subject out. We have the variable X. In this case, this is an existential statement, so we're going to go EX, and then we need an X variable in here. Now we add the predicates car, broken, and rust buckets to the subject. So we're going to say that X is a car, that X is broken, and that X is a rust bucket. Again, we'll talk more about how to put in these operators, but I'm just going to finish this sentence out really quick so you can see the whole thing in its completion. So some cars are broken rust buckets. There exists an X such that X is a car and X is broken and X is a rust bucket. The quantifier, they're the operator that this EX is governing is the operator between car and broken rust bucket. And again, we'll talk about how to figure that stuff out as well. And then we're going to enclose everything so that the quantifier works with all three of your X's. And look, I'm missing an X here. Let's put that X there right after R for rust bucket. So now you have, there exists an X such that X is a car and X is broken and X is a rust bucket. Piece of cake, right? No, I know. It's still tough. Don't worry. Wait, what? Okay, here's another way of thinking about it. Think of the variables as a group of unformed atoms. So that lowercase x that is to the right of all your predicates. So if I had cx, bx, rx. Okay, we're thinking of the variable as a group of unformed atoms. So this x is an unformed group of atoms. This x is a group of unformed atoms. This is the same group of unformed atoms. So here we have the same x all three times, but this x is just some unformed cluster of atoms. And we need to form that cluster of atoms. How do we do it? We need to give the atom some properties. So let's first make the atoms into a car. Boom, done. Second, now that we have made those atoms into a car, we need to break it. Done. There. And finally, now that we have a broken car, let's go ahead and make it a rust bucket. Done. And that's what we've done with the relation between the x and the predicate all three times. Still not feeling it? Last try. Imagine everything in the world disappeared except for 5 boxes. We know something is inside each box, but we don't know what that thing is. So all there is in the world are these 5 boxes. There is something in each box, but I don't know what it is. The x is what is inside the box, and the statement is going to tell you what that x is. For example, some cars are green. I now know that at least one of the things, that's what the EX, for some we're going to say EX. I know that at least one of the things in the world is a car. So there exists an X such that X is a car, and that thing is also green. So of our remaining 5 things in the world, 1, 2, 3, 4, 5. This is it. Zombie apocalypse happened. All we have left in the world are 5 things. What do I know? I know that at least one of them, there might be more, but at least one of them is a car. So one of those undefined things is a car, and one of those undefined things is green. So I have a green car. At least one of those boxes will have a green car behind it. Boom, there it is. Okay, and it turns out we have 2 green cars. So there exists an X such that X is a car and X is green. All right, some cars are green. Okay, let's move on to the next example. We don't know what's hidden behind these 5 boxes, but we know something's behind each box. All of the cars are green. So I now know that for every single thing left in the world, X, if it is a car, then it is green. So here's how we'd write that one. For every X, if X is a car, then X is green. So anytime I see a car now behind that box, it must be green based on what this statement says. Let's see what we got. Boom. Let's see. I have a car. What do I know about it? It's green, sure enough. I have another car. What do I know about it? It's green, sure enough. Here's another car. What do I know about it? It's green, sure enough. Wait, what's this over here? It's an orange helicopter. But this statement told me that for every X, if X is a car, then it's green. It doesn't tell me that everything is a car. It just says if it's a car, then it's green, which in other words is saying all cars are greens. So remember, this doesn't say that everything is a car and everything is green. It's just saying that if it's a car, then it's green. And this is why the universal operator, the operator that the universal quantifier governs, is going to be a horseshoe. because when you put the horseshoe there, it's not claiming that everything in the universe is green and it's a car. In that case, I'd have to turn this helicopter that's orange into a green car, and I'd have to turn this other orange helicopter into a green car as well. So you don't say that everything in the universe is a car and it's green. You say of everything in the universe that if it's a car, then it must be green. And now you have the statement that more accurately reflects the world. Okay, let's try another one. All of the blue cars are missing their tires. So I now know that for every single thing left in the world, if it is blue and if it is a car, then it is missing tires. So let's write that statement out. You have for every x, if x is blue and x is a car, then x is missing its tires. All of the blue cars are missing their tires. The quantifier that the operator that this quantifier governs is the main operator here. That's the horseshoe operator. And again, we'll talk about how we figure out which one's the main operator being governed by the quantifier in a minute. But we haven't connected our quantifier to the last x of the mx. And so we need one more set of containers. We're going to use the square bracket to enclose everything together. And now this is going to be the statement. Let me read the statement out one more time. So for every x, if x is blue and x is a car, then x is missing its tires. Let's see how that looks once we lift up the boxes. Boom. So here we go. We have x is blue, x is a car, and x is missing its tires. The second one is red, so we're not talking about it. Once again, let me write that statement out. We have for every x, if x is blue and x is a car, then x is missing its tires. So the first one, we had a blue car. What do we know about it? It's got to be missing its tires. The second one is red, but we're looking for a blue car, so we don't really have anything else to say about that. The third one is blue, so we met the first criteria, but it's not a car, it's a helicopter, so we don't have anything to say about that. The fourth one is blue, and it's a car, so what do we know? Then it's going to be missing its tires, and there we have it. And the last one is green, but once again, we're looking for blue cars. And the statement was for every x, if x is blue and it's a car, which the first and fourth one are, then it's going to be missing its tires. Okay, that's the best I got for conceptualizing it. If you still don't get the conceptualization, I'd finish this video through and then go back and really focus on the conceptualization part, do the reading and see if there's any other ways. And if you come up with any ways, please let me know. If there's more ways to conceptualize this, I'll keep throwing them out there. But these are the best three I could think of. The way of thinking of it, first as a blob, or second as a group of undefined atoms, or third as mystery things behind the box that you're just kind of identifying what they are. Okay, let's move on to the next part. Here's how the second thing to know works. Several steps. First step, draw a vertical line at the subject-predicate split of each simple statement. Hint, if there are no operators, there is just one simple statement. 2. Assign letters to all aspects of your subject and all aspects of your predicate. 3. Use containers to enclose all aspects of your subject together and all aspects of your predicate together when needed. You're going to assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. 4. You're going to assign a proper quantity, either universal or existential, for each simple statement. You're going to put a horseshoe at the subject-predicate break for the universal statements. You're going to put a dot at the subject-predicate break for the existential statements. And you're going to use containers to bind each simple statement in its entirety to its respective quantifier. 5. You're going to use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. Okay, let's practice some of these. 1. Some grapes are green. So I'm just going to start now walking through the steps and solving this through. So step 1, we're going to draw a vertical line at the subject predicate split for each simple statement. We have some grapes are green. So we're going to put a split right at your subject predicate break between grapes and green. There's no operators, so this is just one simple statement. On to step 2. Assign letters to all aspects of your subject and all aspects of your predicate. There's just one aspect of the subject, it's a grape, so I'm going to give that a letter G. And there's just one aspect of the predicate, and it is green. I'd like to use G again, but I'm not. I'm going to use the letter R just because that's the second letter in there. So we have a grape, and it is green. We're going to use containers to enclose all aspects of your subject together and all aspects of your predicate together when needed. We just have one aspect of a subject, one aspect of a predicate, so we don't need any containers. We're going to assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So we're going to assign an x to the G and an x to the R. Then we're going to assign a proper quantity, universal or existential, for each simple statement. In this case, we only have one simple statement. We're dealing with a sum statement, which is particular, so we're going to use an EX. We're going to put a horseshoe at the subject predicate break for universal statements. This isn't universal. We're going to put a dot at the subject predicate break for existential statements. This isn't existential. So we're going to take here this EX. It is going to govern the break right here. And so we're going to put a dot right between the GX and the RX. Again, we're putting that dot right at the subject predicate break of this sentence. Then we're going to use containers to bind each simple statement in its entirety to its respective quantifier. So we need to take this whole simple statement, grapes are green, and we're going to bind it to that quantifier. So we're going to put parentheses around the whole statement, and then I'm going to put some parentheses around that EX. And now we've done that. And finally, use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. There are no other operators to deal with, and so this statement is done. All right, that's the first one. Let's try another one. Some French cafes are not recommended. From the beginning, draw a vertical line at the subject's predicate split of each simple statement. So let's see here. We have a French cafe, and it is not recommended. So I'm going to put a line right on the word R. Hint, if there are no operators, there's just one simple statement. I don't see any other operators. That is an operator, but remember it's a modifying operator. It doesn't connect things, and so this is not doing its own thing. So we're going to leave that alone for now. 2, assign letters to all aspects of your subject and all aspects of your predicate. Let's see here. So we have this thing we're talking about is French. It is a cafe, and we have it being recommended. And let's go ahead and put that not there so we don't forget to use it. So that's not recommended. So we have a French cafe that's not recommended. Use containers to enclose all aspects of your subject together and all aspects of your predicate together when needed. In this case, our subject, we have two components. It is French and it's a cafe. So we're going to enclose that all together now. The predicate, not recommended, doesn't need any containers. We're going to assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So we're going to put x is French, x is a cafe, x is not recommended. All right. Assign a proper quantity, universal or existential, for each simple statement. So here we have some French cafes are not recommended, so that's an EX. Put a horseshoe at the subject predicate break for universal statements. No, this is an existential statement. Put a dot at the subject predicate break for existential statements. So we're going to put, this is an existential statement, it's an EX. So we're going to put a dot right there. Use containers to bind each simple statement in its entirety to its respective quantifier. So now we need to bind this whole statement, this French cafe that's not recommended, to the EX quantifier. I'm going to use a square bracket to accomplish that. I'm going to be sure to put that EX in parentheses. You'll always put the EX or the X by itself. The quantifier will always go in parentheses. Next step, 5, use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. In this case, we have an operator that needs to be here linking all aspects of the subject. What would connect the French with the word cafe? Is it something that is French or a cafe? No. Is it something that if it's French, then it's cafe? No. This is something that is a French thing and it is a cafe. So it's a French cafe that's not being recommended. So here's the whole statement. There exists an X such that X is French and X is a cafe and X is not recommended. Okay, let's try this last one. Experienced mechanics are well paid only if inexperienced ones are lazy. Step one, draw a vertical line at the subject predicate split of each simple statement. So we see here in the middle of this one that only if is going to be a horseshoe operator. And if you're forgetting this, just go back to the beginning, the refresher. I mentioned this over there. The beginning of this video, I talked about how you have the simple statements are linked together with operators to make compound statements. So in this case, we have a compound statement. The left side is going to be one simple statement, and the right side of that horseshoe is going to be a second simple statement. So we're drawing a vertical line at the subject predicate split of each simple statement. In this case, we have experienced mechanics as our first subject. You have your subject predicate split of R, and then well paid is your predicate side of that simple statement. Then the second simple statement is inexperienced ones and lazy. Okay, step two, assign letters to all aspects of your subject and all aspects of your predicate. So we have E for experienced, we're going to have M for mechanics, and we're going to have W for well paid. Then we're going to have inexperienced. Initially, I'd like to call that an I, but if you look in the beginning, it says experienced. And so you see a distinction between experienced and inexperienced. Well, we're just negating our E there. It's a not experienced mechanic. So we're going to go negation E for inexperienced. And then the ones, we don't need to call it one here, O for one here, because really what is it pointing to? It's an inexperienced mechanic. So we're just going to call that an M as well. And then we're saying L for lazy. Okay, let's keep working on that. Use containers to enclose all aspects of your subject together and all aspects of your predicate together when needed. So here, experienced mechanics, those are all aspects of your subject. Well paid, it's just W for well paid, so we don't need any containers working on that. Going to your second statement, inexperienced mechanics, we're going to use a container to enclose all aspects of that together. And then L for lazy, we don't need anything to enclose that because it's just one letter as well. We're assigning a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So we're going to go ex, mx, wx. Then we're going to go ex, mx, lx. All right. Assign a proper quantity, universal or existential, for each simple statement. Experienced mechanics are well paid. I'm taking this to mean all experienced mechanics are well paid, so we're going to give that an X. Only if inexperienced ones are lazy, I'm taking that to be a universal one as well, so I'm going to give that an X as well. Put the horseshoe at the subject predicate break for universal statements or a dot at the subject predicate break for existential statements. We have a universal statement in for the first one. The subject predicate break is between experienced mechanics and well paid, and we're going to put a horseshoe there. Then the other simple statement, we have a horseshoe again for that X, and we're going to put it right at the break between inexperienced ones and the lazy. Okay. Use containers to bind each simple statement in its entirety to its respective quantifier. So we need to connect everything with the first statement to that quantifier. So we're going to put a square bracket before the experienced and after the well paid. And then the second simple statement, we're going to bind everything to its quantifier. So we're going to put a square bracket right before inexperienced and after lazy. Then we need to use context to identify the remaining operators, specifically operators linking all aspects of the subject and the operators linking all aspects of the predicate. So here we need to link the experienced and mechanics, make that, figure out what operator connects those. And that seems straightforward to me. That person is experienced and that person is a mechanic, so we're going to use a dot there. It's not that they're either experienced or they're a mechanic. It's not if they're experienced, then they're a mechanic. It's that they're experienced and they're a mechanic, so an experienced mechanic. The second one, inexperienced mechanics, same thing. I would say they're not experienced and they are mechanics. So you have somebody that's not experienced and they're a mechanic. And that's the last step. So that's the translation for this one. Okay, let's move on to the next set of translations. Okay, next one. A thoroughbred won the race. Draw a vertical line at the subject predicate split of each simple statement. So we have a thoroughbred as the subject, and what did that thoroughbred do? It won the race. If there are no operators, there's just one simple statement. So this is just one simple statement. Assign letters to all aspects of your subject and all aspects of your predicate. So here we have T for thoroughbred, and W for won the race. Use containers to enclose all aspects of your subject and all aspects of your predicate together when needed. Don't need it. Next one, assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So we're going to assign an x to the t and an x to the w. 4, assign a proper quantity, universal or existential, for each simple statement. This is talking about a thoroughbred, so I would call it an existential. Put a horseshoe at the subject predicate break for universal statements. Put a dot at the subject predicate break for existential statements. So this one is going to be a dot because it's an existential statement. We're putting that at the subject predicate break. And then we're going to use containers to bind each simple statement in its entirety to its respective quantifier. And we're done. 5, use context to identify the remaining operators, specifically the operators linking all aspects of the subject and operators linking all aspects of the predicate, but we don't have any that are needed there, so we're done. All right, next one. A room with a view is expensive. Now take note here, the word a is weird sometimes. A thoroughbred won the race. You can imagine that meaning there's a single thoroughbred that won the race. But now go into a hotel and ask for a room with a view. And if the front desk says, oh, a room with a view is expensive, do you take that as a universal or a particular statement? That strikes me as a universal statement. Even though they say a room with a view is expensive, it strikes me that they're saying if you want a room with a view, that's going to cost you money. In other words, they're saying all of our rooms with views are expensive. So even though this says a, this really strikes me more as a universal statement. Let's keep that in mind as we continue translating this. Step 1, draw a vertical line at the subject predicate split of each simple statement. So a room with a view is expensive. We have is our subject predicate split. If there are no operators, there is just one simple statement. We don't have any operators here, just a simple statement. Assign letters to all aspects of your subject and all aspects of your predicate. So here we have a room, it's got a view, and it is expensive. Use containers to enclose all aspects of your subject together and all aspects of your predicate together. So let's see, the room, and it's got a view that's enclosed. There's just the expensive for your predicate, so you don't need anything else. Assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So we're going to go rx, vx, and ex. Assign a proper quantity, universal or existential, for each simple statement. In this case, a room with a view is expensive. I just talked about that. I think this is a universal statement. We're putting a horseshoe at the subject predicate break because this is a universal statement. Put a dot at the subject predicate break for existential statements. Use containers to bind each simple statement in its entirety to its respective quantifier. So we need to bind this whole statement to this quantifier. We're going to put a square bracket in the beginning and close it off at the end, and now it's bound to that quantifier. And finally, use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. We need to deal with this room with a view part. So it's not a room or it has a view, it's a room and it has a view. So we're going to use a dot operator there. So a room with a view is expensive. We would say for every x, if x is a room and x has a view, then x is expensive. All right, next one. A room with a view is available. Let's see. Here's a again, but let's think about how this one works. A room with the view is available. I go to the front desk. Hey, do you have a room with the view? And they say, a room with a view is available. Do you think they're saying all rooms with views are available? Or are they saying, we definitely have one that's available? It strikes me that they're just saying they at least have one that's available. In which case now this a room with a view becomes a existential or particular. Let's try this translation here then. We have step 1, draw a vertical line at the subject predicate split of each simple statement. So it's available. A room with a view is the subject side, and then available is the predicate side. 2, assign letters to all aspects of your subject and all aspects of your predicate. So we need to go, it's R for room, V for view, and A for available. 3, use containers to enclose all aspects of your subject together and all aspects of your predicate together. So we're going to enclose all aspects of our subject, the room and view together. The predicate is just available, so we're going to leave that by itself. Assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So we're assigning the variable there to R, V, and A. Step 4, assign a proper quantity, universal or existential, for each simple statement. In this case, a room with a view is available. I think that's a existential, so we're going to put an EX in front of everything. And for the existential, we're going to put a dot at the subject predicate break. So after room with a view and before available goes the dot. And then we're going to use containers to bind each simple statement in its entirety to its respective quantifier. So we're going to put a square bracket before room and a square bracket closing it out after available. And the final fifth step is to use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. Here we have room and we have view. We need to link those together. And I would say that there exists an X such that X is a room and it has a view. And so there is your final answer on that one. A room with a view is available. There exists an X such that X is a room and X has a view and X is available. Next set. Hurricanes and earthquakes are violent and destructive. Step 1. Draw a vertical line at the subject-predicate split of each simple statement. Here I'm seeing a subject-predicate split, that word are. If there's no operators, there is just one simple statement. I'm going to go ahead and leave this one as one single simple statement, or treat it like it's a single simple statement, even though you could technically break it up into a much bigger statement. I could say hurricanes are violent and destructive, earthquakes are violent and destructive, or we could get really complex and say hurricanes are violent and earthquakes are violent and hurricanes are destructive and earthquakes are destructive. But I'm going to go ahead and just leave this alone and treat it as one simple statement. So here's how that would work. Assign letters to all aspects of your subject and all aspects of your predicate. So we're going to go H for hurricanes, E for earthquakes, V for violent, D for destructive. Then we're going to use containers to enclose all aspects of our subject and all aspects of our predicate together. So we're enclosing H and E for hurricanes and earthquakes. That's our subject. And then we're going to enclose violent and destructive together because that's our predicate. Assign a variable X to all aspects of your subject and the same variable to all aspects of your predicate. So we're going to go X for hurricane, X for earthquake, X for violent, X for destructive. Okay. This is a really depressing translation we're doing. Number 4, assign a proper quantity, universal or existential, for each simple statement. It strikes me here that it's saying all earthquakes and hurricanes are violent and destructive, so we're going to use a universal quantifier. Then the next step, we're going to take that universal quantifier, we're going to put a horseshoe at the subject predicate break. And we're going to use containers to bind each simple statement in its entirety to its respective quantifier. So we're going to treat this again as a single simple statement, even though I understand you could break it up into 4 simple statements if you really wanted to. So now we've bound everything to that universal quantifier. And then finally, we're going to use context to identify the remaining operators, specifically the operators linking all aspects of the subject and all aspects of the predicate. I'm going to start with the predicate side. So violent and destructive, we have and is the dot operators. It's those things, the earthquakes and hurricanes are violent and destructive. But now we really need to focus on the beginning of step 5. It says use context to identify the remaining operators. This is where the context really matters. So as we read this, think about it. Even though the word is and, think about the meaning of this sentence. Hurricanes and earthquakes are violent and destructive. Are we talking about things that are like hurriquakes or earthcanes, like it's a hurricane earthquake combination like South Park's Man Bear Pig, it's just one thing? I don't think so. I think really what this statement is saying is a hurricane is violent and destructive and an earthquake is violent and destructive. In which case we're not going to use a dot connecting hurricanes to earthquakes. Instead we're going to use a wedge. And so the way this reads then is for every X, if X is a hurricane or X is an earthquake, then X is violent and X is destructive. All right, next example. Every penguin loves ice. We got this. Step 1, draw a vertical line at the subject predicate break. We got Every penguin, what do? They love ice. All right. Step 2, assign letters to all aspects of your subject and all aspects of your predicate. We have P for penguin, L for loving ice. Use containers to enclose all aspects of your subject together and all aspects of your predicate together when needed. Don't need it. Assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. Px, Lx. Step 4, assign a proper quantity, universal or existential, for each simple statement. We're dealing with every penguin, so that's going to be an x. And then we're going to put a horseshoe at the subject predicate break for the universal statement. And we're going to use containers to bind each simple statement in its entirety to its respective quantifier. Done. We're going to enclose the px and the lx. And then 5, use context to identify the remaining operators. We don't need any more operators, so we are done with this one. Piece of cake. Next. Skaters and dancers are energetic individuals. Ugh, I thought things were getting easier. Let's try this one. Number 1, draw a vertical line at the subject predicate split of each simple statement. So skaters and dancers, we have are, drawing a line at the subject predicate split. If there are no operators, there's just one simple statement. This one has that and as well, but I'm still going to treat it as one simple statement, even though technically you could say skaters are energetic individuals and dancers are energetic individuals. You could break this up into two different statements. I'm going to treat it as one simple statement though. So assign letters to all aspects of your subject and all aspects of your predicate. So we're going to call skaters, dancers, there's the subject, and then energetic individuals, they're energetic, and they are individuals. 3, use containers to enclose all aspects of your subject together and all aspects of your predicate together. So we're going to enclose skaters and dancers together, and then we're going to enclose energetic and individuals together. We're going to assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So x to skaters, x to dancers, x to energetic, x to individual. Then we're going to assign a proper quantity, universal or existential, for each simple statement. I take this as saying that all skaters and dancers are energetic. So I would say x for the universal. And then we're going to put a horseshoe at the subject predicate break for the universal statement. So we're going to carry that horseshoe all the way over. Put it right there. And we're going to use containers to bind each simple statement in its entirety to its respective quantifier. So we got to bind all of this to the x. All right. And then finally use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. So energetic individuals, it strikes me that this should be linked with a dot, so they are energetic and they are individuals. Skaters and dancers, even though that's an and, I don't think an dot operator works for the same reason we didn't do it for the earthquakes and hurricanes. I wouldn't do it for skaters and dancers. It's not that you're a sancer or a dater. Actually, a dancing skater, a dater, those are very different things. I don't know what to call that one. A scancer would probably be the technical term for a skating dancer. So I'd put a wedge here. And now to read this all together, we're done. I would say for every x, if x is a skater or x is a dancer, then x is energetic and x is an individual. Last set, here we go. A good violin is rare and expensive. Step 1, draw a vertical line at the subject predicate split of each simple statement. Step 2, assign letters to all aspects of your subject and all aspects of your predicate. So we have G for good, V for violin, R for rare, E for expensive. Step 3, use containers to enclose all aspects of your subject together and all aspects of your predicate together. So we're enclosing the good with the violin, and we're enclosing the rare with the expensive. Then we're going to assign a variable x to all aspects of your subject and the same variable to all aspects of your predicate. So gx, vx, rx, ex. Step 4, we're assigning a proper quantity, universal or existential, for each simple statement. A good violin is rare and expensive. Does that mean there is a good violin that's rare and expensive, or does it mean if you're going to find a good violin, then you got to pay up for it? I think it means the latter, that you know what, anytime you find a good violin, it's going to be rare and expensive. They're just hard to come by and they cost a lot. So I'm reading that as a universal statement. We're putting a horseshoe connecting the subject to the predicate here. So the X is going to go with a horseshoe. So we'll put that in between the good violin and the rare and expensive on the right side. We're going to use containers to bind each simple statement in its entirety to its respective quantifier. So we enclose it all by putting a square bracket on the left of good violin and on the right of rare and expensive. Okay. And then finally, use context to identify the remaining operators, specifically the operators linking all aspects of the subject and the operators linking all aspects of the predicate. So a good violin, I think that's a dot there. You have something that's good and it's a violin. And what are we saying about it? It's rare and expensive. We're saying that, yeah, that thing is rare and expensive. So here's the whole thing read now. For every X, if X is good and X is a violin, then X is rare and X is expensive. 2 more to go. Neither Wordsworth nor Shelley was Irish. Now for this, take a pause, go back to the beginning when I talked about the first thing you need to know. Wordsworth is a specifically named person. Shelley is a specifically named person. So we don't deal with the quantifiers now because we have a specifically named person. So this makes our job a little bit easier. We have lowercase, you do the name, Wordsworth, and then in capital is what we're saying about them. The predicate part is Irish. And then we have Shelley, lowercase the name, capital is the Irish. Again, this is the beginning when I, up here, we're currently on the second thing to know. What this translation is bringing us back to is the first thing to know. So remember, it's just a whole different approach. So you have Wordsworth is Irish or Shelley was Irish, and now you just translate like normal. So neither, you'd say not either Wordsworth nor Shelley was Irish, and that's this translation. Personally, I think these ones are easier. They go back. They remind me of the earlier types of translations before we were dealing with predicates. So this just says neither Wordsworth was Irish nor Shelley was Irish. Last one. If all mysteries are interesting, then Rachel is interesting. Let's start with the easy move. If all mysteries are interesting, then Rachel is interesting. We have an if-then statement, so we have a horseshoe. We're going to break this horseshoe into its 2 different statements now. Let's focus on the Rachel is interesting part. So Rachel is a specifically named person. So we're just going to go lowercase her name and then capitalize the predicate, she's interesting. So we have capital I for interesting and lowercase r for Rachel. Now let's work on the left side of this horseshoe statement. So we're dealing with all mysteries are interesting, and that's all we focus our attention on right now. So we want to draw a vertical line at the subject predicate split. We're going to assign letters to all aspects of the subject and all aspects of the predicate. So we're going to go M for mystery, I for interesting. We're going to use containers to enclose all aspects of the subject and all aspects of the predicate. We don't need that. We're going to assign a variable X to all aspects of the subject and the same variable to all aspects of the predicate. We're going to assign a proper quantity for each simple statement. This is going to be an all because it's all mysteries. So we're going to use a X universal quantifier. And then we are going to put a horseshoe at the subject predicate break for this universal statement. And then we're going to use a container to bind this simple statement in its entirety to the X. We're going to use context to identify the remaining operators. We don't have any remaining operators, and we are done. Now, if you look at this horseshoe, some of you might be thinking, do we need to keep enclosing to get this IR part tied into that quantifier? The lowercase r is its own thing. It's not that lowercase x. And the quantifier just needs to deal with all of the variables that the quantifier is dealing with. So you only need to bind or enclose things so that they connect to the quantifier if they are the same variable as the quantifier. So this R for Rachel isn't an X, so it doesn't need to be enclosed or contained along with that X. And so we're done.